Welcome to week 21 of Algebra 1 with Mrs. Whybark. This week we will continue our discussion of quadratic functions. We will be learning about how to find solutions. When we are interested in finding the solutions to a quadratic function, there are three different methods that we can use. The first is the graphing method. When we graph a quadratic function, you'll recall we find the line of symmetry. That's the line about which the parabola is able to be reflected. We then find the vertex, and we can also find the y-intercept. Those are helpful points to graph a parabola. Once we graph the parabola, in order to find the solutions, we look for the x-intercepts. And the x-intercepts are where the parabola crosses the x-axis. There are several names for these. They are called solutions, x-intercepts, roots, and zeros. So in this particular example, there would be two solutions to this particular parabola. They would be x equals -1 and x equals 3. So we would say that the solution set contains the numbers -1 and 3. This is example 1 on the first page of your guided notes. Looking at this parabola, can you find where the x-intercepts or solutions are to this parabola? If you look carefully, you'll see that the parabola crosses the x-axis at x equals -3 and x equals 1. There are two solutions to this quadratic function, so the solution set is the numbers -3 and 1. In example 2, this parabola actually only touches the x-axis once. So there's only one root or one solution to this function. And in this case, it is where x is equal to 3. So the solution would be x equals 3, and the solution set would contain only one number, the number 3. This is what the first page of completed notes should look like in your guided note packet. Example 3 is on the second page of your guided notes. And in this particular case, you might notice that this parabola does not touch the x-axis at all. So this is a special situation in which we say that there are no real solutions. That means that there's no x-intercept at all. So the solution set is actually the null set. The second method for finding the solution or roots of a quadratic function is to factor and solve for x. We've already learned how to do this during our unit on factoring. In example 4, which is on page 2 of your guided notes, we start with the function x squared plus 5x plus 6 equals 0. On your notes, there's a place for you to list the 4 steps to solve using factoring. The first step is to make one side equal to 0. You then factor, and in this case we would factor this trinomial to get two binomials, x plus 3 and x plus 2, which equals 0. So step 3 is to set each factor equal to 0. That gives us x plus 3 equals 0, or x plus 2 is equal to 0. We then solve each equation. When we solve x plus 3 equal to 0, we get x equals -3. And when we solve x plus 2 equals 0, we get x equals -2. Therefore, the solution set contains the numbers -3 and -2. That means that there are two solutions to this quadratic function. Example 5 on your guided notes is x squared minus 4x minus 12 equals 0. So again, we make one side equal to 0. We then factor, and when I factor this trinomial, I get two binomials, x plus 2 times x minus 6. And this is all equal to 0. So I set each of these binomial factors equal to 0. That gives me x plus 2 equals 0. When I solve this one, I get x equals -2. And I get x minus 6 equals 0, and when I solve this one, I get x is equal to positive 6. So my solution set contains the numbers negative 2 and 6. Page 2 of your guided notes should look like this when completed. There is a third method for finding the solutions to quadratic functions, and it's a little formula we call the quadratic formula. The quadratic formula can be a little bit cumbersome to use. Therefore, we often like to check the discriminant before we use the entire formula just to get an idea of how many solutions we will find. The discriminant is a component of the quadratic formula, and it is b squared minus 4ac. There's a spot for you to write this down on your guided notes. Also include that if d is less than 0, meaning the discriminant is a negative number, there will be no roots or no solutions. When the discriminant is equal to 0 exactly, there will actually be one solution. And when d is greater than 0, meaning that the discriminant is a positive number, there will actually be two solutions. Take a moment to jot those down on page 3 of your guided notes. Next, we are going to take a look at how to solve a quadratic equation using the quadratic formula.
Behold! This is the quadratic formula. The solutions for the equation are x equals negative b plus or minus the square root of the quantity b squared minus 4ac, all divided by 2a.
Wow, that's a mouthful.
This formula is written in shorthand notation, and this symbol means plus or minus. When a quadratic equation is in standard form, we substitute the values of a, b, and c into the quadratic formula to get the two solutions, x equals negative b plus the square root of the quantity b squared minus 4ac all over 2a, or x equals negative b minus the square root of the quantity b squared minus 4ac all over 2a.
This is what page 3 of your guided notes should look like when completed. Please take a moment to fill in the information and catch up. This next example is example number 6 in your guided notes. Please follow along and fill in the information as we go.
Solve the equation x squared plus 3x plus 5 equals 0 using the quadratic formula.
A equals 1, B equals 3, and C equals 5.
Substitute these values into the quadratic formula. Replace A with 1, B with 3, and C with 5.
Now simplify.
3 squared is 9.
4 times 1 times 5 is 20.
9 minus 20 is negative 11.
Hold on. We can't take the square root of a negative number. The square root of negative 11 is not a real number.
You're right, Lizzie. That's why this equation has no real solution.
If we had taken a moment to use the discriminant before using the entire quadratic formula, we would have realized ahead of time that this quadratic function has no real solutions because the radicand, or b squared minus 4ac, comes out to be a negative number. So we could have saved ourselves a little time and realized that this equation would have no real solution.
In this case, the solution set is the empty set.
Use the quadratic formula to solve the equation 2x squared plus 1 equals 3x.
This is example 7 in your guided notes. Please follow along and fill in the problem as we go.
First, we write the equation in standard form. We need to put all of the non-zero terms on the same side.
So let's subtract 3x from both sides. 2x squared minus 3x plus 1 equals 0.
Because the terms on the right are in descending order, this equation is in standard form. Now we're ready to identify the values of a, b, and c.
A equals 2, B equals -3, and C equals 1.
Substitute those values into the quadratic formula. In the formula, replace A with 2, B with -3, and C with 1. Then simplify.
The opposite of -3 is +3.
-3 squared is +9.
4 times 2 times 1 is 8.
9 minus 8 is 1.
The square root of 1 is 1.
In the denominator, 2 times 2 is 4.
Remember that this equation is shorthand for two equations. The plus or minus sign means that x equals 3 plus 1 divided by 4, or x equals 3 minus 1 divided by 4.
Solve the first equation.
3 plus 1 is 4, and 4 divided by 4 is 1.
Now the other equation. 3 minus 1 is 2, and 2 divided by 4 is 1/2.
X equals 1 or x equals 1/2. The solution set consists of 1 and 1/2.
Because these solutions are rational numbers, this problem could have been solved by using the factoring method.
Sometimes it takes a lot of time to find the right combination when solving by factoring, so using the quadratic formula may save you some time.
This next example is example 8 on your guided notes.
In question 1 of your guided notes, solve the equation 3x squared plus 6x plus 3 equals 0 using the quadratic formula.
A is 3, B is 6, and C is 3. When you substitute those values into the quadratic formula, you get -6 plus or minus the square root of the quantity 6 squared minus 4 times 3 times 3, all divided by 2 times 3.
Next, we simplify.
6 squared is 36.
4 times 3 times 3 is 36.
36 minus 36 is 0.
The square root of 0 is 0.
2 times 3 is 6.
Write the two separate equations. X equals -6 plus 0 divided by 6, or x equals -6 minus 0 divided by 6.
Simplify each equation. -6 divided by 6 is -1.
The solution set has only one element, -1.
That means if we were to graph this particular quadratic function, we would get a parabola that would touch the x-axis only once, and it would happen to touch the axis where x is equal to -1. And this is page 4 of your guided notes. Thank you for watching this Whybark production.